Hi, the purpose of today's video is to summarize one particular type of linear systems application problems. I call these the speed problems. They deal with situations where an airplane is flying either with the wind or against the wind, and we have to use that information to find the airspeed of the plane and the speed of the wind itself. A lot of times the problems will be, instead of planes, it's a boat traveling in a river, so it's going with the current or against the current. It's the same general concept and the same really basic structure too. So if you recognize that you have a problem that's dealing with speed and we're going with and against a current or a wind, then you can use this structure every single time and it's going to work for you. And so I not only want to show you what the structure is, but also explain to you why it makes sense. So first of all, we can express, and people in science do this all the time, we can express forces as vectors, or basically arrows. The longer the arrow, the more fast or forceful the object is moving through space. So this arrow represents wind speed, and it's less than this arrow, which represents plane speed, because the plane's usually flying faster than the wind. But the concept here, and it's a fundamental concept, is if the wind is going the same direction as the plane, then those two forces combine to give you a total speed with the wind. So if I add the wind speed to the plane speed, then I'll know how fast the plane was traveling with the wind at its back. On the other hand, if the plane is traveling in the opposite direction as the wind, that is, the wind is going against the airplane, then the plane speed will be reduced by the wind speed. In other words, the wind causes the plane to go significantly slower because they are opposing forces. So where the sum of the two forces gives you the speed of the plane with the wind, the difference of the two forces will give you the speed of the plane against the wind. So this structure is really, really helpful for us because basically we don't even need to know any of the details. We know that wind speed plus plane speed equals the speed with the wind, and we know plane speed minus the wind speed will be the speed against the wind. It's that simple. So notice over here though, now we got a problem, and it says with a tailwind, a small aircraft, a Piper, can fly 600 miles in 3 hours. And against the same wind, so assume the wind's going the same speed, the Piper can fly the same distance, but it takes 4 hours. With that information, I can figure out how fast the wind was going, and I could also figure out how fast the airplane was traveling. In order to do so, I go to the last sentence, which says find the speed of the wind and the speed of the Piper, which means those are my variables. W for wind speed and P for airplane speed. And we measure the speed, in this case, miles per hour. It's important to use those labels, and I'll show you why. Because in this structure it says wind speed plus plane speed. I'm going to write over here W, miles per hour, plus P, miles per hour. And on the other side, I need to have a miles per hour. I have to have speed plus speed equals speed. Now when I look into the paragraph, I see 600 miles. And some people are often inclined to just put the 600 there. But this wouldn't make any sense because it's it's W miles per hour plus P miles per hour equals 600 miles. It's not possible to add two speeds together and get a distance. I could also put the 3 on the other side, but that would mean speed plus speed equals hours, and that doesn't make any sense either. I'm not given the actual speed of the aircraft with the wind. However, by telling me 600 miles in 3 hours, they're telling me the speed. In other words, if you travel 600 miles in 3 hours, you're literally traveling at 200 miles per hour. That's what you get when you reduce this. These divide out, and you're left with miles per hour. So the reason why it's useful to use your labels when you're writing your variables is it helps you make sure that the number on the right-hand side of the equal sign is the same kind of number as the numbers on the right-hand or left-hand side. So again, we have W miles per hour plus P miles per hour equals 600 miles every 3 hours. Similarly, if I take the plane speed and subtract from it the wind speed, it's miles per hour, I still travel the same 600 miles, but it takes 4 hours. It makes sense it should take longer. Now, if I get rid of the labels and reduce the numbers on the right, I'm going to get a system that looks just like a textbook system. Easy peasy. This is going to be super easy to solve. So getting the solution to this system is not really the issue. It's how do we take a paragraph and turn it into a system that I can solve. So the reason I put this lesson together as a video is because I want to show you that this structure is useful even if the information that's given is slightly different than the way it's given here. Here's the example I want to use. It says the average airspeed of a single-engine aircraft is 150 miles per hour. if the aircraft flew the same distance in 2 hours with the wind and 3 hours against the wind, what was the wind speed? Sorry, I tried to type this and I typed it wrong, so I just tried to fix it real quick on the fly here. So basically what we're doing is we're traveling a certain distance, and it takes us 2 hours when the wind is at our back, and it takes us 3 hours when the wind is at our front. So it's asking what the wind speed is. Now here's why this is more interesting than the previous problem. I'm actually told the speed of the aircraft is 150 miles per hour. Recall earlier, I had to find the speed of the aircraft and the speed of the wind, but here it's telling me that the speed of the aircraft is 150 miles per hour. So that makes it a little bit trickier. The one thing about this that's a little bit tougher is it doesn't say anything about the other variable. You have to imply it here, specifically if the aircraft flew the same distance. I was never told that distance, so I'm going to call that distance my other unknown. And it will be the same in both equations because it says the aircraft flew the same distance. So I'm going to let W equal the wind speed in miles per hour, but I'm going to let distance be d, and I'm going to measure that in miles. So why is this important to make sure you keep track of your labels? Because I'm not going to be able to add w plus d because one's a speed and the other is miles. Can't do it. However, I do know some rates. I know the rate 150 miles per hour is the speed of the actual aircraft. I also have a structure that says if we go with the wind, it's plane speed plus wind speed equals total speed. If we go against the wind, it's plane speed minus wind speed equals total speed. So, what else do I know? I don't know. I know 150 miles per hour is the wind, or is the plane speed. W miles per hour is the wind speed. If I add those two together, I get the total speed, which is measured in miles per hour. Well, I go back to my information over here, and I can see that I do have an hour. There's a time. With the wind, 2 hours. So I could put it 2 hours down at the bottom, but the distance is unknown, so I leave it open. But d over 2 represents a speed in miles per hour, where d represents a distance in miles. Now I'm going to do the same thing, except we're going against the wind this time. We've got 150 miles per hour minus the wind speed in miles per hour equals something else miles per hour. It's the d distance in 3 miles per hour. Once again, you can strip the labels away, and you can do a little bit of cleaning up. I multiplied by 3 and 2 respectively, or 2 and 3 respectively, to end up with a nicer looking system in slope-intercept form. But back to the actual writing of the system, just notice that in the previous problem, I didn't know the speed of the plane or the wind, and I had to find both of those as my unknowns. But I used wind plus plane equals total, plane minus wind equals total. And over here, I knew the speed of the aircraft, but I was still able to write the system because I was able to say plane speed plus wind speed equals total speed, plane speed minus wind speed equals total speed, and it works just fine. It creates a system with two variables that I can solve just like before. Again, what was really helpful is paying attention to our labels to make sure that we don't do something silly like putting D on the right-hand side in miles when we have everything in miles per hour on the left-hand side. So that's the part that reminds us that we got to factor in the 2 hours and factor in the 3 hours in order to get a proper speed on the right-hand side. Remember, too, we're writing linear systems, so we always have to have two variables. And that's why I need to write distance as an unknown, because I needed another variable to write a system. Anyway, we have another one where a small plane travels 800 miles in 5 hours. This is just to show you how easy this becomes once you know your structure. It says find the velocity of the plane and the wind. So I say plane speed and wind speed. Add them, you get 800 miles in 5 hours. Subtract them, you get 800 miles in 8 hours. Boom, you got your system. So by having a structure, it takes a lot of the pain and suffering out of the process. Here's one that's totally different. 16 kilometers downstream with the current in 2 hours. Upstream 16 kilometers against the current in 4 hours. We need to know the rowing speed of the boat and of the current. Well, this seems really familiar. It's not airplanes, it's boats, but the same thing can be said. We have rowing speed in kilometers per hour. We have current speed in kilometers per hour, and we're going to take the rowing speed plus the current speed, and that's going to equal S speed in kilometers per hour. Rowing speed minus current speed equals speed in kilometers per hour. Nice, easy system, good to go. So I hope you find this helpful. Anytime you're dealing with a speed problem and you're dealing with linear systems, just use that structure that I showed you at the beginning. Just remember that picture right here. then you'll know what the basic structure is going to be, and you'll get all your points. Have a nice day.